Hello class, and welcome to section 10.5, which is all about the Pythagorean theorem. By the end of the lesson, you'll be able to use the Pythagorean theorem to solve for missing sides of a right triangle, and you will be able to determine if a triangle is a right triangle using the converse of the Pythagorean theorem. So in order to understand the Pythagorean theorem, we first need to understand the vocab for a right triangle. So a right triangle obviously has three sides because it is a triangle, and one of the angles is a right angle or a 90-degree angle. The hypotenuse is the side opposite from the right angle. This is always going to be the longest side of your right triangle. The legs are the two sides that actually come together to form that right angle. The Pythagorean theorem then states if a triangle is a right triangle, then a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Building off that, a Pythagorean triple is a set of numbers that work for the Pythagorean theorem. So for example, not 2 squared, 3 squared plus 4 squared is equal to 5 squared. So 9 plus 16 is equal to 25. So a Pythagorean triple would be 3, 4, and 5. That is something that works for the Pythagorean theorem. The converse says the opposite of the theorem. So if the sides of a right triangle satisfy a squared plus b squared equals c squared, then it has to be a right triangle. So if you have three side measurements that work for this equation, then there has to be a right angle in that triangle. So first thing we're going to use is the Pythagorean theorem to find a missing side. So we have 10 and 24. Those are our two legs because they form the right angle. It doesn't matter if you call 10A and 24B or vice versa. You just need to pick. So now plugging in, I have 10 squared plus 24 squared is equal to c squared. So we just plugged our values into the equation. 10 squared is 100. So I've got 100 plus 24 squared is 576 is equal to c squared. Adding those together, I get 676 is equal to c squared. In order to get rid of squared, we need to take the square root. So in order to find c, I take the square root of 676 and I find out that c is equal to 26. So that means my hypotenuse has a length of 26. Go ahead and try this one on your own. Plugging in your numbers for a and b, squaring them, adding them, and then taking the square root, we end up with c is equal to 97. We can also use this theorem to find the legs of a triangle. So right now, we know that the hypotenuse, or our c value, is 15. And they give us b, which we don't know, so 7 is a. So I'm going to plug in and I'm going to say 7 squared plus b squared is equal to 15 squared. Again, you're going to want to solve those square roots. So 7 squared is 49, and b squared stays as is. 15 squared is 225. In order to get b squared by itself, we are going to have to get rid of the 49. So we subtract 49 from both sides, which gives us b squared is equal to 176. In order to get rid of the squared, we're going to take the square root of both sides, which is going to give us an answer of b is equal to 13.27. Again, rounding to 2 decimal places if there are decimals involved. Go ahead and try this one on your own. So we've got our hypotenuse, our long side is 75, b is 25, squaring both of those, subtracting the 625, and then taking the square root. If you simplify it in radical form, you're going to get 50 square roots of 2. You are not required to do that. I just showed that if you wanted some extra practice on a topic earlier from this chapter. If you got the decimal answer, your answer is going to be 70.71. So I would accept either of those answers on the test for this particular concept. The next look at is, are these values forming right triangles? So we've got 16, 9, and 12. The first key thing to pick out, which one is the hypotenuse? So you are always looking for the longest side. So 16 is going to be your C value. Again, it doesn't matter which one is A and B. So I'm going to plug in and I'm going to say 9 squared plus 12 squared is equal to 16 squared. 9 squared gives me 81. 12 squared is 144. And 16 squared is 256. 81 plus 141 is going to give me 225. 225 is not equal to 256, so the answer to this would be no, because it is asking us if it is a right triangle. Coming over to this next one, again, looking for the long side, that's going to be 50. So I'm going to say 40 squared plus 30 squared is equal to 50 squared. Squaring 40, I get an answer of 1,600. Squaring 30, an answer of 900. And squaring 50 is 2,500. Adding 1,600 and 900 is going to give me 2,500. Since those two are equal, we get an answer of yes, this is a Pythagorean triple. So if it works out that they are equal, it is a right triangle, it is a Pythagorean triple. If it works out that it is not equal, then it is not a right triangle. Go ahead and try this one on your own. This problem works out so they are not equal, so this is not a right triangle. If you have questions about this or anything else from the lesson, please let me know when you get to class.